Hello everyone, my name is Fatih Sevinç, and today I will be talking to you about the differences between LEDs and lasers. Uh, let's get started. Yes. I would like to introduce you what a LED is firstly, then we can talk about lasers and we can get into more details about the differences between both of them. Uh, well, light emitting diode is the longer way of saying the LED. LED is obviously the shorter way of saying it. Is a semiconductor PN junction device that gives off spontaneous optical radiation when subjected to electronic excitation. The electronic excitation is achieved by applying a forward bias voltage across the PN junction. This excitation energizes electrons within the material into the excited state, which is unstable. When the energized electrons return to the stable state, they release energy in the process, and this energy given off in the form of photons. And you can see a model picture in the downside right here. Next slide, yes. Features of LEDs. In this list you can see a couple features and qualities about LEDs. Let's take a look at them. LEDs are semiconductor materials. Semiconductor means they're not fully conductor, but they're not non-conductor either, so they're somewhere between. Its main ingredients are silicon. We know what silicon is, yeah. When current passes through it, they emit light, releasing photons. When the current passes through it, they are releasing photons. That's the important part about LEDs, I assume, yeah. They are produced to give light at different angles. Well, obviously, you know where LEDs are used generally, and they're supposed to look good most of the time. So they give the lights in different angles, which can make a good view for the people looking at it. Yeah. The voltage current graphs of LEDs are exponential. A small voltage change on the LED, and when it is at the appropriate operating point, causes a large current change. A serial current limiting resistor is connected to the LEDs to avoid distortion due to high current. Yeah, that's of course good for the security. Security right now. A serial current limiting resistor is connected to the LEDs. Yes. Let's reduce a constant voltage on them, just like the just like a Zener diode. It says yes. We can get to the next one. Structure of LED. This part is about showing it. Nothing much to talk about it. Yeah. As you can see how it works. It's a small model here. Advantages of LED. Later on we will also talk about advantages of lasers. So this part is particularly important in order to compare both two. It will be in the future at least. It is a simple design. Ease of manufacture. It's easier to get, which is always good. Simple system integration. Well, simplicity is always good. It's easy to manufacture. Low cost, high reliability, simple fabrication, simple drive circuitry. Linear light output against current characteristics. Less temperature dependent. Well, briefly, advantages of LED are it's cheaper and easier to get, which is obviously an advantage, yeah. Disadvantages of LED. This part is also important because when we get to talk about lasers, we will also talk about the disadvantages and advantages of lasers, and we need to see them here. First one, refraction of light at the semiconductor area interface. The average lifetime of radiator recombination is only a few nanoseconds, therefore modulation BW is limited to only a few hundred megahertz. Low coupling efficiency, usually low optical power, coupled into fiber. Large chromatic dispersion. Areas of use of LEDs. On mobile phone keys, yeah, at flashlights, garden and home lighting, in computers, in screen making, LED screens, obviously you know the name LED screens, it's pretty famous, yeah. Lighting systems of automobiles. Well, that might be a surprising thing because we all know about lighting systems of automobiles. But personally, I didn't know that it was all about LEDs. In short, wherever you can think of lighting, yeah, makes sense. It's cheap, easy to do. LED types, well, in this list you can clearly see a couple of LED types. Of course, their usages are different, but the way they work is generally pretty much the same, so yeah. Well, right here we get to next part in our comparison. It's the second part. What is a laser? What is a laser? It was supposed to be, but there's a mistake here, okay. Lasers are devices that make it difficult for electrons at high energy levels to produce normal light by spontaneous passage, and electrons at low energy levels to reach higher energy levels by absorbing light, allowing the number of electrons in excited passage to be higher. Electrons pass spontaneously, emitting normal light from high energy level to low energy level, and excitation from a low energy level to high energy level by absorbing light are undesirable situations for lasers. Features of lasers. Laser light is very intense and intense compared to light source. Well, yeah, we didn't talk about intensity when we were talking about LEDs, which can be considered a difference here. While normal lights are scattered in all directions, the laser beam is not dispersed and can be focused. The deviation tolerance is almost minimal. It's a pretty neat light. Well, this is a very important point because when we talk about LEDs, we were talking about it going at all angles. When we are talking about lasers, it can focus, unlike the LEDs, yeah. Third one, laser beam has very single wavelength. Because of this feature, it has monochromatic feature. Fourth one, the laser beam is a beam of light with high amplitude and parallel waves of monochrome at the same phase. Very precise processing and processing can be done with laser beam at high energies. Well, obviously that's something we all know. Sixth one, the laser beam has more brightness than other light sources because, you know, it's more dense and intense. It's focusing on something which makes it brighter. Structure of laser, just like we showed the structure of LEDs before, in this model you can see the structure of laser. Obviously it's not going at all angles, it's following one line, which we called it focusing on something before, yes. So I'm getting to the next one. Advantages of laser. Simple economic design, just like the LEDs, we also talked about them being pretty cheap. Second one, high optical power. Well, that's different than the LEDs, obviously, we have talked about it. Third, production of light can be precisely controlled. Well, this is coming from the quality of lasers being able to focus, which cannot be told about the LEDs. Fourth one, can be used at high temperature. Well, yeah, we knew that. Fifth, high coupling efficiency. Sixth, low spectral width. Well, obviously this is also about it being not going to different angles, at different angles. Seventh, high radiance compared to LED. Well, obviously in seventh we can talk about the difference because it obviously states the difference openly. 8, modulation capabilities up to GHz range. 9th, ability to maintain intrinsic layer characteristics over long periods. And here we have disadvantages of laser. At the end of fiber, a speckle pattern appears as two coherent light beams add or subtract their electric field depending upon their relative phase. Second, the laser diode is extremely sensitive to overload currents and high transmission rates. Well, these are obviously disadvantages. Areas of use of laser: industry, medical industry, scientific research, engineering, meteorology, communication, holography, defense equipment. You can see simple pictures of it being used. Laser obviously is for unwanted areas. Female friends will probably recognize it. Yes. Laser types, well, just like we had talked about the LED types before, we are now talking about laser types. There are solid lasers, semiconductor lasers, liquid lasers, chemical lasers, and gas lasers. Comparison chart, well, this is like a brief summary of the entire slides. Working principle, you can see the differences. Full form, response. Obviously, lasers have faster response than LEDs. Well, I think we have all checked the differences briefly now. We had already been talking about them for a while. Difference between LED and laser. Parameters: LED, laser. Full form: light emitting diode, light emitting stimulation. Low power, high power. Obviously, we know that lasers have higher powers because they are more focused. Broad spectrum, because it LED's optical spectral width, it has a broad spectrum because it goes at all angles. Lasers have much narrower width because it's focusing. Modulation bandwidth: tens of kilohertz to hundreds of megahertz, tens of kilohertz to tens of gigahertz. Well, these are differences. As you can see, yes, being non-coherent and coherent. Little temperature dependence, very temperature dependence. Well, a lot of temperature dependence. Let's say it would be better to say in that way. Yes. Key differences between LED and laser. Well, here we see more important and brief ways of saying some differences, and it's not in a table, so it will be more explaining. Yeah. First one, the light beam produced by LED and laser also creates a key difference between laser and LED, LED and laser, or let's say. The light emitted by laser consists of various colors, while the light beam produced by laser consists of a single color. Second, the working principle of LED and laser also created major differences. Laser works entirely on the principle of electroluminescence, which means illumination by means of electrons. At the other hand, laser works on principle of stimulated emission. Third one, another key difference between LED and laser is the junction area. The area of junction in case of the laser is extremely narrow, as light allowed to pass from extremely small area in case of the laser. At the other hand, in the LED, junction area is wider, thus light is allowed to pass through over a wide area. Well, it's because, lasers are able to focus on something and LEDs are not. Fourth one, the concentration of charge carriers such as electron holes are also different in LED and laser. In case of the laser, the concentration is very high, while in LED it's very low. Thus, laser is used in surgical instrument in the medical field, as it possesses sufficient energy that it can even cut the object in contact with it. Laser versus LED, difference in structure. Well, we had already showed the basic models of them being different, so there's a small passage about them being different also here, if you want to read it. LED fiber optic light source is made of materials that affect the wavelengths of the emitted light. A basic LED light source is a semiconductor diode with a P region and then N region. When the LED is conditioned, current flows through the LED. As current flows through the LED, the junction of the P and N regions emits random photons. LEDs emitting in the 820 to 870 window, usually gallium, aluminium, arsenide. Yeah, you can see the shortwave writing it chemically. The laser is also semiconductor diode rather than diode with a P and N region like LEDs, but it provides stimulated emission rather than unidirectional self-emission of LED. The main difference between a LED and a laser is that the laser has an optical cavity, which is necessary for it to be permanent. The cavity is created by splitting the opposite end of the chip to create highly parallel, reflective, mirror-like finishes. Laser versus LED, difference in speed, transmitting distance, and cost. Well, the general difference between them is that LEDs is the standard light source, which is short for light emitting diodes. Laser light source like gas lasers may be mainly used in some special cases. Lasers are more powerful and operate at faster speeds than LEDs, and they can also transmit light farther with fewer errors. Lasers are also much more expensive than LEDs. Well, that's obviously because of the quality differences between them. And one more time, my name is Fatih Sevinç, and you can see my student number here. I'm a mechanical engineering student, currently in the second year of my program. Thanks for listening to me. Have a nice day.